Alright, 8.2 is about similar polygons, and our objectives are to identify similar polygons and apply similar polygons. So first we need to know that similar figures have congruent corresponding angles and proportional corresponding side lengths. And the mathematical symbol for similarity is just that little wavy line. The similarity ratio is the ratio of the lengths of the corresponding sides. Then there's this thing called a golden rectangle, and it is a rectangle that can be divided into a square and a rectangle that is also similar to the original. So you're splitting one rectangle into two pieces. You'll have a square and a rectangle that's similar to the rectangle you started with. Then the golden ratio is the length to the width ratio of the golden rectangle, which is about 1.618, and we will be using that number, so that's a good number to remember. First example, understanding similarity. So measure of angle B is equal to, we're trying to figure that out. Well, we know the measure of angle B has to be congruent to the measure of angle Y. Since the measure of angle Y is 78, the measure of angle B is also 78, because we know those two triangles are similar. Then we're trying to figure out BC over YZ is equal to something over XZ. AC corresponds to XZ, so BC over YZ is equal to AC over XZ. Okay, there's one check for understanding problem for you to do. Use the pictures from example 1, and this will be just like what we were doing in example 1. Okay, then example 2, determining similarity. So we're going to determine if the parallelograms are similar. So first we need to check for corresponding sides that are proportional. AB over JK is 2 over 4. BC over KL is 1 over 2. CD over LM is 2 over 4. And DA over MJ is 1 over 2. So all of those reduce to 1/2. So the corresponding sides of the two parallelograms are proportional. Now we need to check that the corresponding angles are congruent. Angle B corresponds to angle K, but angle B does not equal angle K. So the corresponding angles are not congruent. Although the corresponding sides are proportional, the parallelograms are not similar because corresponding angles are not congruent. Alright, example 3 says use similar figures. If triangle ABC is similar to triangle YXZ, find the value of x. Because they are similar, you can write and solve a proportion. So AC over YZ is congruent to something over XZ. Now, BC corresponds with XZ, so BC should be on the top. And corresponding angles are proportional, or corresponding sides are proportional. So then if we substitute things in, we should have x over 50 equals 12 over 40. Then we need to cross multiply. So x equals 12 over 40 times 50. If we multiply all of that out, x equals 15. And our last example, example 4, use the golden ratio. The dimensions of a rectangular tabletop are the golden ratio. The shorter side is 40 inches. Find the longer side. So L is the longer side of the table. So L over 40 equals the golden ratio 1.618 over 1. So if we use the cross product property, 40 times 1.618 is going to be the length of our table. So if we multiply that out, we get 64.72. Okay, there are a couple more check for understanding problems for you to try here. The first two are about similar triangles, or similar shapes, and the last one is about the golden rectangle. So go ahead and try those and let me know if you have any questions.